Okay, so I have an infinite series, and I want to determine whether or not this infinite series converges. Some of you may be gravitating towards the root test. You wouldn't be wrong there, but I would caution you to be very careful. Don't distribute your square root over addition, and you may need to use some inequalities there. But that's not the route that I'm going to take. So I'm going to start by noticing that the terms in this series are all positive, because sine squared is positive or non-negative, and those limits tend to infinity. And if a sequence tends to infinity, then it's going to end up being positive eventually. In fact, every single term in this series is positive, but you just need to show that they are eventually always positive. And what that does is it lets us reorder the terms. So first I'll split up this fraction, then I'll separate it into two infinite series, and now I will rewrite that e to the j over pi to the j as e over pi to the j. So looking just at that first sum, sine squared I over pi to the I. Sine squared I is always between 0 and 1, so it is strictly less than 1 over pi to the I. And I know that 1 over pi to the I converges just by the geometric series test. In the same way, e over pi, that's equal to 0.866. Remember, e is 2.71-ish. Pi is 3.1415-ish, and so this fraction is going to be less than 1. So the sum converges, again by the geometric series test. And since each of these infinite sums converges separately, and since I'm allowed to reorder terms, that means that the entire sum converges. And so I'm done. I have convergence now.